All right, crew. Thanks for joining me today. Hey, look, today we're going to take a look at what Nvidia had to say at their new, I guess, product release or software release here at Siggraph. And, I watched it for the first go live and I was like so impressed. I mean, the thing about Nvidia, like Nvidia deliveries, is like the animations, the visuals, they're just so dang good. So, anyway, I was thinking, like, hey, look, let's take all the highlights, let's take all of those very nice animations, throw them together, talk about them, review them together, and then expand on them, right? We're going to talk about some of the new enhancements and eventually show some of the new enhancements in my next videos. So we're going to start off here with the intro from the man himself, the guy who says all the right things with so much awesome content behind him.
AI is revolutionizing the largest industries, including computer graphics. Nvidia researchers, applying the AI capabilities that our GPUs enable, are now reinventing 3D graphics. The incredible advances of AI and 3D
Man,
graphics
the fire,
have
the
laid the
visual,
foundation
just
for the
incredible.
next computing platform, the next big evolution of the internet, the metaverse.
The metaverse. What is the metaverse? This is such a great question. I feel like if I just ask 100 random people, like, hey, what's the metaverse? They're gonna be like, and I'm gonna get 100 different answers, right? Or there's some. For kicks, I just asked a couple of my buddies on teams, hey, what do you think of the metaverse? I like, wait, what do you think it is? And two of them replied, Ready Player One. I was like, you know what? That's not a terrible way to look at it. I mean, like, I was thinking that now that they said that, I can't get that out of my head. But it's like, yeah, avatars, characters, online, interacting in that online world, 3D via some sort of like haptic suit or VR, AR goggles or something, and then essentially the whole internet that we have now migrating to that, plus all of these other things. It seems interesting. But we're gonna hear what Jensan has to say about the metaverse. So let's take a look.
What is the metaverse? Simply, it's the next evolution of the internet. Commercialized 2 decades ago, the internet was about web pages, hyperlinked over a network. A decade ago, Web 2.0 emerged, and the internet was about cloud services, connected to applications that are oftentimes enjoyed on mobile devices. Now Web 3.0 is here. The metaverse is the internet in 3D, a network of connected, persistent, virtual worlds. The metaverse will extend 2D web pages into 3D spaces and worlds. Hyperlinking will evolve into hyperjumping between 3D worlds. Like games today, 3D worlds are experienced through 2D displays and TVs, and on occasion with VR and AR glasses. What are metaverse applications? They're already here. Fashion.
So augmented reality, right? I can tell you this right now. Like these. So I teach obviously, right? Teach at university, and this is like what students want to do. This is what that generation of new learners who eventually will become developers, who will eventually become users, right? This is like right up their alley. Like this is the end goal. And so, we talk about this now, we think, oh, that's so far in the future, but I really don't think it is, and apparently, people are doing it right now. But I'm just saying that's like there's a really big buzz around this at the university level.
Designers, furniture and goods makers, and retailers offer virtual 3D products you can try with augmented reality. Telcos are creating digital twins of their radio networks to optimize and deploy radio towers. Companies are creating digital twins of warehouses and factories to optimize their layout and logistics.
So I think the digital Earth thing is so cool. They're showing two here, rather than like the actual Earth and the digital Earth. But like, think about how that could expand. Like we're just modeling 1-to-1. Let's just say, and say, hey, here's what the weather is now. Here's what it might look like in the future. But then, what if AI took over that simulation, right? And we weren't just running one calculation. We were running 1,000 calculations, and then based off that 1,000 calculations, we select the 3 or 4 that are best and run another 1,000, and based off those 1,000, 3 or 4 that are best, and then select another 1,000, and then that propagation continues. And because we have AI essentially that will eventually converge to the actual solution. You can think of this as like a whole like field of dominoes, and then if one domino doesn't fall over, then that thing doesn't cascade. But what about all the other ones? And so it's like which dominoes are actually cascading in real life, and how is that being replicated in the digital twin, and how many different variations can we get? Well, the reality is, it's like, if we're just talking about 1,000, why not 10,000? And if it's like, why not 10,000? Why not 100,000? Right? And so, like, I look at this and I see so much promise of this, like in this technology, the digital twin technology, especially when applied to like the Earth and climate change, and just all the things that are going on, either at the weather level or how we're impacting the global climate. I just think this is just really, really cool and fantastic. And the fact that Nvidia is spearheading this is pretty awesome too, I feel like, because then I don't have to deal with how biased maybe the data is, right? I'm just like, yeah, well, Nvidia has nothing to gain about this. This is their application running the simulation, versus like the very drastic websites. They either swing one way or the other. Hey, there is no climate change. This is the normal ebbs and flows of the Earth. Or there is climate change. We're going to kill the Earth in 10 years. It's like the two drastic approaches of this. So I think, just from like the engineering standpoint, and someone who wants to receive data, essentially, like, not from the media, you know what I mean? I just want the data. That this is pretty cool.
And Nvidia is building a digital twin of the Earth to predict the climate decades into the future. Nvidia's AI research is impacting every aspect of computer graphics. RTX, the fusion of programmable shading, ray tracing, and AI, has started the next era, neurographics. Neurographics will be integral to how artists create 3D worlds and how the world is animated and rendered. One of the most impactful neurographics inventions is DLSS, an AI that has learned to enhance the resolution of motion
DLSS,
graphics.
if you're a gamer, you know exactly what that is, right? It's essentially like a denoiser for your live renders, or the live graphics that are on the screen, right? Takes all the noise out of it. What is it? DLSS, deep learning super sampling, right? DLSS. Wait, let me look that up real quick. I feel like I should get this content right for you guys. Yeah, deep learning super sampling. Yeah, that's what it is. It's pretty intuitive. I think in the engineering world, engineering, like, or maybe like the rendering world, we would equate DLSS to like some sort of denoising.
The metaverse will grow organically as the internet did, continuously and simultaneously across all industries, but exponentially because of computing's compounding and network effects. And as with the internet, the metaverse is a computing platform that requires a new programming model, a new computing architecture, and new standards. HTML is the standard language of the 2D web. USD, Universal Scene Description, an open and extensible language of 3D worlds invented by Pixar, is likely the best language for the metaverse. Nvidia Omniverse is a USD platform.
Hey, Omniverse, yes. I'm a huge advocate of this tool. I think it's just really fun, really cool. And the fact that like Nvidia isn't trying to put a piece of software out there that replaces something else is pretty refreshing, because it seems like everyone's just competing over everything, right? Whether you're in CAD or rendering or some sort of like 3D studio design software, right? Like everyone's just chomping at the same bit for like the shared amount of resources. But the reality is, Omniverse plays with everything. It's the Omni and Omniverse, right? You take your CAD files, take your Maya files, take your 3D Studio Max renders, take your OBJs, your scenes, your FBXs, and then put them all into one interface, have them all play together. So I've been keeping my eye on Omniverse for about the last year, and just the amount of stuff that's on the exchange and the library and stuff that you can put in your library has drastically increased. So keep in mind too, we're going to be reviewing this content actually in Omniverse and some follow-up videos. So be sure to stay tuned and subscribe.
a toolkit for building metaverse applications, and a compute engine to run virtual worlds.
Ultimately, neural graphics will redefine how virtual worlds are created, simulated, and experienced by users. There are many important challenges to address in the world of computer graphics. Let's talk about a few of these and the solutions provided by neural graphics that can revolutionize the field. Content creation is a time-consuming process. The exquisite craft of artists remains essential, but combining AI and graphics can help significantly streamline this process. One way to save time is to take pictures of a scene or an object and try to reconstruct it in 3D. We can think of reconstruction as the inverse of the rendering process, going from images back to a 3D representation.
So this is fantastic. It's like this simplified version of scanning, right? So we think of scanning as like this highly engineered thing, and you get scanned data and you have to match it to other data, and you're looking for heat maps and quality control and offsets and all this fancy stuff. And sure, there's that whole realm of scanning. It totally applies. It's actually really incredible that we can do this. But then how do we simplify this so that everyone can use it? Well, everyone has a camera. Everyone has a phone, right? With a camera on it. Take some pictures of an object. Like around the latitude, maybe some longitudinal pictures. And then generate a 3D off of it so that we can use it in our USD. So we can use it and save it in USD, and then, edit it, move it, shade it, color it, render it, whatever we want to do in Create and View, or simulate on it, right? And create an Omniverse View. I thought this was actually incredible because the biggest roadblock for me as a user is finding the assets. And if it's not finding the assets, then me generating the assets. And that even takes longer, right? So if I can just go download some sort of generic file online and then convert it to an OBJ and then put it in my scene, we're great. If I can find something that already exists in the Omniverse directory, right, and then use it in the scene, great, right? If it's close enough, But then being able to take something just off the cuff and take some pictures of it and then throw it in the scene, incredible, right? Thinking about doing that to my office. I'm not sure how that'll work, but I feel like I should give it a shot. Or maybe I'll start off small. We'll do like my mic or something, and then scale it up from there. But this is really great.
By parameterizing the 3D scene with neural networks and optimizing this representation using classical rendering techniques in the loop, you can achieve high-quality results in a single unifying framework.
Incredible.
Here's
another example of that, played through 4 pictures, 360 around the object, or the person in this case.
The metaverse is the next era in the evolution of the internet, a 3D spatial overlay of the web, linking the digital world to our physical. Many of these virtual worlds will be reflections of the real world, linked and synchronized in real time. Many of these virtual worlds will be designed for entertainment, socializing, and gaming, matching the real world's laws of physics in some cases, but often choosing to break them to make the experiences more fun.
So what you were seeing actually in that video there was view. We were seeing the playback. Use the viewer create. It played real quick. But we're actually seeing like the physics take place or the renders happen, right? And so that kind of just shows you how important Omniverse is, right, to the metaverse. In a sense, you would argue that Omniverse fuels the metaverse, right? All the content is accumulated there and then pushed out. So, yeah, fun stuff, the metaverse. Keep in mind, these are just the highlights, so I clipped through some of them. There were some abrupt changes there. But I was just trying to condense this all down so we could talk about it.
Devices and robots will act as portals between our physical world and virtual worlds. Humans will portal into a virtual world with VR and AR devices, while AIs will portal out to our world via physical robots. The next era of the internet, the 3D internet, or metaverse if you will, needs a standard way of describing all things within the 3D worlds. We believe universal scene description, invented and open sourced by Pixar, is the standard scene description for the next era of the internet. USD is far more than a static file format. It's a 3D composition engine with APIs for composing, editing, querying, rendering, collaborating, and simulating virtual worlds. USD is unique, giving 3D artists, designers, developers, and world builders the ability to work in non-destructive, layered workflows. The framework is highly extensible, providing the ability to build custom schemas for specific workloads or industry applications.
Nvidia is enhancing USD to support extremely large and complex digital twins.
Again, it wouldn't be an
Everything from
Nvidia
sprawling
video
factories to global
without
scale climate
all the
change.
awesome graphics.
Digital twins need to operate in full design fidelity at real-time speeds and optimized for different devices. Here are the ways that Nvidia is extending USD to scale to the scene complexity of digital twins. The source USD is compiled into Fabric, a GPU-accelerated, deeply vectorized data representation for real-time updates, shown here in Drive Sim. Just-in-time optimizations like mesh merging and material distillation reduce scene complexity while preserving visual fidelity, and can be applied at load time without modifying the source data. This is crucial for making a ground truth representation of a digital twin available to both.
Okay, to simplify that, I just think what they're saying is, hey, look, we're optimizing everything to make this attainable for, you know, like a guy with like a normal desktop machine here versus someone who's running crazy computations with a ton of data, say off a server. You don't really know how bad like data size can be until you are either a victim or someone who has to deal with like the support or the, you know, the fixes or the how-tos. And I got to tell you, you know, a good portion of my time yearly is just spent on file management, data management, reducing file size, optimizing files, reducing, you know, just the file size altogether, providing workarounds, teaching people about different modes, like per se in SolidWorks, like large design review or large design mode, lightweight, etc. Or, you know, coaching people on, you know, hardware. A lot of the times, you know, I'm able to open up the file that they're having issues with, no problem, because, you know, I have 48 gigs of VRAM, you know, and they're tapping out at 8 or 16, right? And their files taking up like 32 or 36. Massive files, right? And it's just like, well, my computer doesn't crash because I don't run out of RAM, right? And you would argue for rendering tools that's the case, and then you would argue for just like CAD files, your motherboard RAM would be the limitation too, right? And whether or not you're running ECC RAM and all these hardware things, it's a huge barrier sometimes. And the fact that Nvidia's like in Omniverse's infancy, that Nvidia is looking that far ahead is very, very promising.
A supercomputer like OVX, as well as a general consumer-grade device. Let's take a look at an example that shows the performance of a digital twin in USD. This virtual factory dataset from the Lotus SD Digital Factory team contains millions of prims in USD. With Nvidia's just-in-time scene optimizers, the first pixels for this dataset appear in just a few seconds. These optimizers can be configured to device requirements on the fly. Without the optimizers, the dataset takes minutes to load, plays back at 7 FPS, and can exhaust GPU
even minutes
resources
isn't bad. We're
on
talking like
lower-end
hours
systems.
in some case.
Let's take a closer look
tools.
at the optimization process. In traditional USD rendering pipelines, Hydra copies the USD data into GPU buffers as is. This is where optimizers come in. We can load the entire scene headlessly into system RAM, and then merge meshes, distill materials, and stream geometry to the renderer. In this case, geometry streaming prioritizes the draw order based on camera heuristics such as solid angle. With these just-in-time optimizations, we achieve a 10 times speedup in load time and a 10 times speedup in playback frame rate. This is just the beginning for where we can take just-in-time scene optimizations. Future work could include out-of-core scene optimization to relax system RAM requirements and much more. USD is the ground truth for digital twins, scalable to any level of available computing power.
The USD ecosystem is vast.
Check out that list. That's pretty good. We're missing one there.
with contributions from
Look
numerous
close,
leading
near and
technology
dear.
companies, not only in M&E, but in
Soon,
AEC,
hopefully.
manufacturing, and even robotics industries. We're partnering with many of these companies to evolve USD and can't wait to see more names on the list.
MDL, material definition language, to simulate physically accurate materials. Physics,
Off to
an
MDL,
advanced
which is
real-time
really, really
physics
important,
engine.
actually.
And RTX, the world's first hybrid rendering engine and AI system that enables us to simulate light and matter with physical accuracy in real time. AI, to assist in building or autonomously generate worlds, make predictions, and automate beyond human abilities. And of course, USD, the powerful scene description standard for virtual worlds.
So I just want to touch on MDL. MDL isn't that new, actually, and you could download the MDL database from Nvidia. I want to say I downloaded it first maybe like 4 years ago. That'd have been 2018. So I've known about them for a few years. I think they've been around quite longer than that. But essentially, like, not all appearances and textures and colors are the same, right? So let's just talk about stuff that I know really well, like the SolidWorks appearances. They look okay, right? When you import them into Visualize, the rendering tool, they look pretty good. And then you apply the Visualize textures, right? The baked in ones into the Visualize tool. And you would argue that those look even better. And better is relative, right? But like better in that there's more options to edit. There's you just get granular with them, more granular. And then you go to the MDL textures, and that's like a step above. So if we're talking about like hierarchy and like the SolidWorks universe of things, right? Which is near and dear to me. You'd have like, the SolidWorks materials or textures and colors. Then you have like the Visualize materials and colors, the baked in ones. And then you have the MDL materials and colors, which you can add to Visualize, right? And so the idea with those is that, one, they're pre-done. So if you wanted like sooty bubbles, right? There's actually like a bubble one that you could just like drag and drop on. So there's not a whole lot of work for you on the user side of things, but then it just looks incredible. And then the fact that this is all married together with inside like a USD, the universal scene description, the 3D interface that we're using in Omniverse, Create and View, is just a bonus. So if there's anything you can do like right now to start working your way in the right direction, like the direction where all this is headed, is if you're using some sort of rendering tool, look at those MDL textures, right? Those MDL appearances, download them, start using them, get acquainted with them. They won't let you down. Boom. Check that out. Amazing. Hey, making me hungry. Look at the fire. Smoke. Mist. Fire. Yep. Looping fire. Physics. Simulations. That just makes me happy.
See you in Omniverse.
I mean, that doesn't get you excited about like where we're headed in the future. I think you should watch it again. Oh man. So there's one thing to remember there, right? Is that someone created all that stuff, right? And truthfully, it wouldn't be an Nvidia video, right? Without, or Nvidia marketing without some sort of awesome visuals. Like I said, I think I've said that twice already, but it's just incredible. But all that stuff was created with the software that's available today. It's not out of your reach, right? It's just a new tool to learn. I have one experience to share with you about Omniverse, Omniverse View specifically, because that's I think where I've spent the most amount of time currently. And that's that I kind of prize myself at being a good clicker because I've used so much software over the years and I've had to learn so many different tools, so many different simulations, renderings, CAD, drawings, like everything in that engineering world, that I've become a good clicker. And I think there's a lot of people in that category, not just engineers, not just CAD people, but anyone who's used software for an extensive period of time, whether it's Rhino, ZBrush, Maya, 3D Studio Max, like, any one of those, any CAD tool, right? PTC Creo, CATIA, Fusion. Like if you fall in one of those categories, you've become a good clicker. And I think with that asset behind you, you're going to find that you can be pretty successful right off the get-go with Omniverse. And, coupled with watching some YouTube videos and learning that these are attainable for you too. Practice makes perfect, of course, and then switching your engineering mind to that creative mind is also a challenge. But if you're a good clicker, it's right there. So let's check out a couple more highlights that I've clipped.
Scale is a flexible language that can be used to define complex, physically accurate materials, like cloth with complex highlight patterns. It defines the ground truth of a material with properties such as energy conservation that enables robust physical simulation. Many renderers can't render such complex materials and need to simplify or translate into their own material model.
Whereas OpenVDB uses a hierarchical tree structure, NeuralVDB introduces neural representations of both values and the underlying tree structure. This dramatically reduces the volume's memory footprint, allowing users to interact with extremely large and complex volumetric datasets in real time, as well as translate and share them more efficiently. NeuralVDB also carries over the GPU acceleration of NanoVDB, which Nvidia introduced in 2021. While these side-by-side examples look identical, the memory footprint of the NeuralVDB representation is up to 100 times smaller.
And that's a huge deal.
To speed up training by up to 2x, NeuralVDB allows the weights of the previous frame to be used for the subsequent frame. NeuralVDB also enables temporal coherency, or smooth encoding, by using the network result from the previous frame. This reduces the need for post-production effects like motion blur.
The fact that they're simulating water there is incredible.
OpenVDB has grown beyond its entertainment use cases into healthcare, industrial manufacturing and design, scientific computing and visualization, robotics, and machine learning applications. By dramatically reducing memory requirements, accelerating training, and enabling temporal coherency, NeuralVDB opens the door to scientific and industrial use cases, including massive, complex volume datasets for AI-enabled medical imaging, large-scale digital twin simulations, and more.
So I think the other thing that they're showing here too is not only Omniverse like omni agnostic as far as like CAD systems go or 3D systems go or whatever it is. You have some sort of 3D file, put it in Omniverse and use it there. But then it's also omni in another way in that it's multi-directional. So, they showed examples of shop floors. They showed examples of topology, like the company that comes to mind, I think is ESRI. They do the topological data, showing how like a fire burns, to the industrial side of things, to the animation side of things to the med device side of things. Like it's omni in that way too. It's omni squared, right? Robust, I guess, is the word, right? Robust software.
Omniverse audio to face is now available with
And
full
audio to
facial
face.
animation and emotion control. Omniverse Machinima now has new content from Beyond the Wire, Postscriptum, and Shadow Warrior. Machinima now has easily accessible AI-enabled animation tools like audio to face and audio to gesture. Lastly, Omniverse Deep Search is now available for enterprise customers.
I wish I had
letting
this.
teams use AI to help them intuitively search through massive untagged asset databases. Deep Search lets you search on qualitative or vague inputs, bringing up accurate results for red rusty barrel. Deep Search works even if the USD data does not contain any tags or other metadata.
It's like
AI,
everything search for Windows.
The most powerful technology force of our time, will revolutionize every field of computer science, including computer graphics. Nvidia's RTX is the engine of neural graphics. RTX and neural graphics is like a time machine.
Wait for it.
The breakthroughs you saw today would have otherwise taken another decade. The power of neural graphics to create worlds and synthesize images is an essential pillar of the metaverse. The metaverse is the next evolution of the internet, the 3D internet. Today, we made 3 major announcements. First, we announced the significant release of Omniverse, including new toolkits for creating USD applications and new engine technologies for running virtual worlds. Nvidia Omniverse runs on USD, the leading candidate for the standard language of the metaverse. Second, we also announced collaborations with industry leaders and an open source suite of USD interoperability tests. Virtual worlds are essential to designing, training, and operating robots, the next wave of AI. Avatars will be among the most popular of the many forms of robots. There will be billions of avatars. Our third announcement, Nvidia ACE, Avatar Cloud Engine, is a suite of AI models used to create avatars of all kinds. ACE runs in the cloud or in embedded systems. The announcements we made today further advance the metaverse, a new computing platform with new programming models, new architectures, and new standards. Our industry is set for the next wave. The combination of AI and computer graphics will power the metaverse, the next evolution of the internet.
Now approaching your destination.
And this is how Nvidia ends it, which is like a really cool flyby. It's very cool renders, lots of interaction. I mean, at this point, it's hard to be more impressed because you're already impressed, you know? Man, look at that. It's like ray tracing on that window.
Hi, welcome to Nvidia.
I like this part. It's the wink. They didn't have to do that, but they could do it, so they did it. Some of this content's reused, but it's just a reminder, I feel like. Yeah, good stuff. All right, so I wanted to wrap this up with showing you some of that new stuff that's in the Omniverse exchange. So we have, well, actually, I'll just show you what's in my library. The stuff that I use, Marbles RTX is pretty fun, especially when you're showing people what you can do with the graphics card that you have, or just an interactive, real-time ray traced game. Showroom's really cool because you can play around with USDs, or you can just like see, it's like a show and tell sort of thing. Here's View, which is what I've been using the most, and then Create, which is arguably the big dog on campus, right? View and Create are probably the two that I'll be getting used to first. But all the stuff that's been added, you go to this exchange and then you can start downloading the parts of the kit that you want access to, right? And so the one, and this is where you get like Marbles and View and Kit and Showroom and all that great stuff. And then they have these connectors. So if you use like Maya or Autodesk Revit, right, then you can have it read directly into Omniverse. So it's like a real-time read. So if you make changes, you can see that happen real-time in your render, which is pretty fun. But furthermore, let's just scroll down the list here and look at the content packs. So this is where you can get your materials database. You have some architectural content you can download, commercial content, industrial content, residential content, game content, like scene content, and then another materials database. So this stuff is really cool. You can just click download, it'll add it. And these weren't there. I don't know when these popped in. I wasn't paying all that great attention to it, but these are definitely new, and you should go check it out. So if you do use Omniverse currently, be sure to go check these out and see how you can use them. All right, crew. That was my highlight reel of what I watched in the Siggraph live video. I just wanted to share it with you because I feel like getting someone else's perspective is somewhat viable, and then also to like generate content and generate conversation about this. So I really like it if you guys chimed in on anything that you liked. Hey, thanks for nerding out with me on this. I definitely had a good time. I definitely enjoyed everything that Nvidia put together. I don't work for Nvidia or anything. I'm just excited about these sorts of things. And yeah, I hope you enjoyed it. I hope you saw something new. I'll link the full version of this presentation that Nvidia did in the comments. And yeah, as always, thanks for watching. Can't do it without you, you viewers, you people who like, you people who subscribe. Thank you very much. And stay tuned for some more videos on Omniverse View, Omniverse Create, some MDL videos. I got a couple of things lined up, so stay tuned. And thanks for watching.
See you in Omniverse.